Hello everyone, this is Benji, local technical support in Denmark, and this is my Loytec L IP 101 guide. Over the years working with the L IP, I first found that it could be hard to understand how the device is working and how to set it up properly. Later I've had to answer a lot of questions about the exact same things that was causing me some headaches initially. I've therefore made this video as an intent to help others getting started a bit easier than I did. Please note that this video is based on the manuals available, as well as my personal experience, but it's not an official presentation, and so product support will not necessarily support everything I mention or present. Before I start, I would like to thank Norbert from Loytec for validating the technical details, as well as everyone else having reviewed the video before I posted it. The content of this presentation is the following. In communication, I'm first going to explain a little about the theory behind L IP communication, and then I'm going to show in practice how to set it up. In applications, I'll show how an L IP network is used in various applications. Last, we'll go through some examples on how to troubleshoot communication problems. So first off, in communication, how it works, selecting the driver, router mode, configuring the L IP, and working with an L IP in a LAN and a WAN environment. A L IP network normally consists of 2 or more L IPs, each having 1 or more physical LAN ports. If only one LAN over IP unit is required, the better option will normally be to use the NIC IP, unless future expansions are planned. In most cases, there will be a PC talking to the L IPs. The driver on the PC acts as a LANWorks EIA 852 device with its own neuron ID, just as the L IP does. A L IP network must have one and only one configuration server, or CS. The configuration server is not a special device, but merely a L IP which has had the CS option enabled. So it's simply a matter of selecting one of the L IPs to be the configuration server. The task of the configuration server is to maintain an updated list of EIA 852 devices, be it L IPs or the PC. You therefore add all the devices to the list in the configuration server, and in the configuration of the devices, you point to the configuration server. When a new L IP comes online and knows what IP address this configuration server has, it will call the configuration server and ask for the complete list of other devices. When the configuration server detects a new device pointing to it or has a new device configured in its list, it will distribute the information of this new device to all other devices. It's a common misunderstanding that the configuration server handles all communication, acting as a bottleneck. This is however not the case. 2 L IPs or PC can talk directly to one and another. Again, the configuration server is purely the phone book, so to speak. When an L IP has connection to the configuration server, the CNIP LED on the L IP is green. If an L IP loses the connection to the configuration server, the CNIP LED will turn orange. The L IP stores the channel routing information in its flash memory, meaning that it can still talk to other devices even though it loses the connection to the configuration server. When an L IP establishes a connection to the configuration server again, the CNIP LED turns green again. If a L IP has been offline, the moment it comes back online, it contacts the configuration server to check if any changes has been made to the device list while the L IP has been offline. Again, until receiving response from the configuration server, the L IP will use its cached routing information. If there are changes, they are sent back to the L IP. If a PC is part of the L IP network, you will need a driver on that PC to talk to the L IPs. There has been various discussions about which driver to use. The reason Echelon's driver is still widely used might be because of the fact that the first versions of TAC Vista didn't support the Orion stack. Here's my opinion on which one you should choose. Using Loytec's driver, you get the benefit of the Orion stack, which gives you minimum 6 times faster communication to the LIP network. This has been tested on a larger site here in Denmark. 655 values were requested from 340 different TAC centers. Using Echelon's driver, it took 64 seconds before all values were updated. With Loytec's driver, it took 11 seconds. This gives the end user a better experience and reduces the engineering time. You don't need any LNS installation on the PC when you use Loytec's driver. If LNS is used, the LNS database is not active during normal operation. This means that if there is a power failure or the PC crashes from some other reason, the LNS database is not affected, and this can save many hours of engineering time. Various applications can use the interface at the same time, which means that you can make an LNS backup and use a protocol analyzer while, for instance, TAC Vista is running. Loytec's driver is the only LUN driver supported in SBO. You need to buy a license to use Loytec's driver with LIPs, but it's a small price to pay compared to what you get out of it, and will save you money in the long run. I would even recommend existing sites using Echelon's driver to change to the Loytec driver. There are essentially 2 router modes available working with LIPs. Either SmartSwitch or Configured Router mode. It requires less configuration to use SmartSwitch, but there are some other benefits using Configured Router mode. Both modes limit the bandwidth usage on the physical LAN channels, but use different methods. In SmartSwitch mode, one LIP doesn't know what is below the other LIPs, so each time a packet from a LAN channel under an LIP should be transmitted to another device over the IP network, the packet is actually sent to all known devices, which then handles the filtering. In Configured Router mode, each LIP knows what is below the other LIPs, so it only transmits the packet to the specific unit. In both modes, the LIP will filter the traffic between its own physical segments, in the same way as we know it from an Ethernet switch. Loytec's advice is not to use more than 10 LIPs in SmartSwitch mode in one LIP network. StruxureWare building operation doesn't support Configured Router mode. The same goes for TAC Vista Classic. However, here in Denmark we have used as many as 50 LIPs in SmartSwitch mode on the same network, but only with very few controllers under each LIP. Loytec recommends using multicast when the LIPs are set to SmartSwitch and there are more than 10. I'm not going to discuss using multicast in this presentation. The router mode can either be set using the dip switches on the LIP or via the web page. When installing a brand new LIP, you need to set up the IP address of the unit as a minimum. The LIP comes with a default address, but don't use that for any device. Either connect to the LIP via its web interface, giving your own PC an IP address in the same range as the default IP of the LIP, or connect via, for instance, hyperterminal to the device. The latter is my personal favorite. In case you don't know the IP address of an LIP, you can either perform a factory reset or simply connect with a terminal to the unit. Now I'm going to show you how to use hyperterminal to initially configure the LIP. When you use hyperterminal, you need to use a null modem cable, also known as a crossed serial cable. Here's the indication of how that cable should look. Open up hyperterminal and make a new connection, giving it a name. Click OK. Select your COM port, which is connected to the LIP, and click OK. Click on Restore Defaults and select 38,400 in bits per second. And click OK. Right now it might seem that you're not connected, but hit enter and you'll see that you are. So for setting the IP configuration, you need to hit the 5 and press enter. Now hit 2 to set the IP address of the unit. Hit enter. Enter the IP address that the LIP is going to have and click enter. Now hit 3 to set the subnet mask. Hit enter. Write the subnet mask. Hit enter. To set the gateway, you hit 4 and write the IP address of the gateway. I'm going to set the DNS servers for this unit, so I hit 7 and I write the IP addresses of the DNS servers. You can also do that from the web interface afterwards. So now to save my IP configuration, I hit the X key and hit enter, and I hit enter again. This will reset the unit when I hit 0 and enter. So now the LIP has restarted and I can access it from a web page. So here I've opened up the web page and I click config and write the password that we saw previously in the presentation. Hit enter, click TCP IP configuration, and I verify that the IP information is correct and the same as I entered in hyperterminal. If we click on CEA 709 over IP, you can see that no config server address has been written. In CEA 709 router, we can see that it's set according to dip switch, which is in smart switch mode. I've set it to. And on the CEA 852 server, we can enable and disable the LIP being a config server. And I'm going to enable it because I want this LIP to be the config server on my network. So I save the settings and reboot the device. And this concludes the initial setup of my LIP. Now we're going to look at how we can apply the theory we have learned in real-life examples. In this example, we are going to work with a setup containing one PC with the Loytec driver and a NIC 852 USB dongle installed. On the network, we have two LIPs, one of them being the config server. Independently of whether we are working with a LAN or WAN setup, the complete route to each LIP or PC must be unique. The route is a combination of IP address and port number. Default ports are UDP 1628 for EIA 852 LAN communication and port UDP 1629 for the config server communication. The config server is the only device using two ports on the same network. Generally, when we talk about ports, we talk about through what port a given device should be accessible. Depending on the setup, a device must be able to communicate to various different ports. More about firewall settings and that later in this presentation. Imagine that you are a person standing on the top level of the network used, in this case the LAN network. When looking at the devices, the port numbers are the same, but as the IP addresses are different, the combination of the two is unique for each device. Here's how to set up this scenario. First I go to my configuration server and click config, write the password and click login. I go to the channel list, click add device, and here I'm going to add the other LIP, so I give it a name that I can remember, and I write the IP address of the other LIP and click save. I have to enable it, so I tick the box here and select enable and click execute. And now the other LIP is online. So essentially the configuration server contacted the other LIP and automatically wrote the correct information. We'll get back to seeing that. I add the PC also with a name and an IP address. Save it, tick the box, select enable and click execute. This one doesn't go online but remains as unregistered, and this is because the driver is not active on the PC right now. So just to check, we open the slave LIP, log in, and click on the device, and we can see here that the config server automatically wrote its information into the other LIP. Alternatively, we would have to have written this information ourselves. So now we configure the driver. We open up lconfig, and the first thing you do is to go down into advanced and select that the driver should run as a service. Click OK and OK. You'll get a message saying that this now started as a service, and on new operating systems that mean that the L doesn't appear in the taskbar in the bottom. So you need to, when you open lconfig, go into the start menu and open lconfig from there. It's located in Loytec network interfaces. So you select NIC 852 tab. First of all, you make sure that the device is enabled. Click Save with configuration, and you write the IP address of the config server. And remember here that the port number has to be the config server port. You can write whatever name you want. You click OK, and now test the device. And you can see that we have connection to the config server and it's communicating. When you go into the list on the configuration server, you reload the list and you'll see now that it's not unregistered but not responding. This is because the driver has been talking to the configuration server but is not doing anything at the time of the reload. This will turn green when you use the application, but if you want to test it, you can quickly click test the connection and then click reload, and then it will turn green. So this concludes the LAN setup. In this example, we are going to work with the same setup as before, with one LAN connection containing the two LIPs, one of them being the config server. But the PC with the Loytec driver and the NIC 852 USB dongle installed is now on another network. We could also have LIPs on other networks, but for the sake of general understanding, I've chosen this configuration. The complete route to each LIP or PC must still be unique. The default ports are still the same. Now the top level is no longer the LAN network, but the WAN network, meaning the internet. As you can see, there's now a conflict between two of the devices, as they, from the top level, do not have a unique combination of IP address and port number. When working with a WAN setup, it's the WAN address we combine with the port number to check if the combination is unique. So we have to change the port number that is used on the second LIP. UDP 1629 is already used for config server communication, so we'll take UDP 1630. Now all combinations are unique. When working with a WAN setup, it's also necessary to make port forwarding or NATing in the routers. Here's how the setup should be made. As the way this is done in various routers can vary, I'm not going to cover that in this presentation. In some routers it's called NAT, others call it port forwarding, and others again call it application and gaming. Please consult your router's manual. Here's how to set up this scenario. I always start up with the configuration server. So I click on config and log in. Then I click on CEA 852 server. And in NAT address I write the WAN IP address behind which this LIP is located. So 11.21.31.41. I reset the device, and while it's resetting I switch to the slave LIP. Click on config, log in, and here, because it's firmware 5, I'm clicking IP. Again, in NAT address, I write the NAT address behind which this LIP is located. Save the settings. Before I reset, remember that on this LIP we had to change the LAN port, or the UDP port. So I click EIA 852 device, and here in config client port, being the port of the LIP, I write 1630. Note here that the config server address has also changed the IP address. Save the settings, click reset, and reset the device. Then go back to the config server, which has now rebooted. Log in, and now I go to the channel list. Here you can now see that the config server has already moved on below a NAT router in the table. But now I have to put the slave LIP below the same NAT router. So I click and mark the tick box right to the LIP and select assign to NAT and click execute. Here you can see that if we try to assign this LIP to the list so it's located below the same NAT router, but we don't change the port, it will conflict. So we write the correct port information that we already configured in the slave LIP. Tick the box, select assign to NAT, click execute, write the WAN IP address behind which it's located, and save it. Now you tick it again, enable it, click execute, and now you can see that the two LIPs are in fact communicating. We have to do the same thing with the PC or the Loytec driver. Tick it, select assign to NAT, click execute, and write the WAN IP address behind which the PC is located, and save that information. Now you tick the box, select enable, and execute. This setup is not going to work in the end because I don't have the sufficient access to the routers. So this is merely an example. You'll have to take my word for it that this will work. We switch back to the lconfig. First of all, we now have to allow NAT routing because the PC is behind the NAT router. Here we again write the IP address, the WAN IP address behind which the PC is located. And now we cannot talk to the config server on its LAN IP address, so we have to write the WAN IP address behind which the config server is located. Click OK. So again, now when we test it, this is not going to work. You can see it's counting up and not showing a good result. And this is because I don't have those two routers. But in theory or in practice, this would work. Do take some time at this point to review the different IP settings we have made in the list and in the driver. This was at least where in the beginning I had some trouble in understanding exactly what information had to go where. But hopefully after this guide, you'll understand it a bit more. And now a bit about using the LIPs in various applications. The simplest of the applications is where no PC is involved. You can use the LIPs to simply make one large LAN network consisting of various small hardwired networks. That way you can engineer everything from one place, even though the customer doesn't have a management system. In some cases, we have had customers that didn't want to expose their network to the internet, but wanted to control the installation from the internet nevertheless. What we have done in these cases is to install a Center 511 or similar connected to the internet through an ADSL connection, and connected the LAN port of the Center 511 to the LAN port of an LIP. That way the customer can control his installation, use the LIPs to save LAN cable installation, and not expose his network to the internet. Another way to use the LIPs is below TAC Vista Classic. Assuming that we already have a working LIP network, it's really simple to add an LIP interface in TAC Vista. Here's how to set that up. Through TAC Vista Workstation, you right-click the Vista server, click New, Device, and Communication Port Loytec. You give the port an appropriate name. I'm going to call mine NIC852. And then first of all, you have to, in Properties, define what a physical interface on the PC should be referred by Vista. I select NIC852 and OK. Then right-click the port, select New, Device, LANWorks Network, give it a name, click Finish. You then right-click the network and select Commission Download. Click the two arrows and Continue, and that commissions the network. Click the server, hit refresh, and you can see that the network is now online below the port. You can now add, as usual, the LANWorks group and the center groups. A little trick on the Loytec port is in Properties, you have max number of concurrent messages. Default is 8. You can set that to, for instance, 1024. What this means is that the Loytec driver through Vista server can handle more concurrent messages on the network simultaneously. Take care with these settings, but in some cases it might give you a quicker communication. The only real difference between TAC Vista Classic and TAC Vista LNS when using the Loytec driver and not the Echelon driver is that you configure the port in TAC Vista through the TAC Vista system plugin. Here's how to set it up. Independently of whether the LIP is set to configured router mode or smart switch, it's always a good idea to place it on the drawing so that the drawing represents the physical installation. The LIP on the drawing has to be set up so it reflects the actual settings in the LIP. If it's a smart switch, the router type in the device should be set to repeater. If, however, it's configured router mode, you need to set it to configured. To service pin the LIP, if it's set to configured router mode, request a service pin. You then switch to the web page in the LIP, and in the bottom you see this Send Service Pin Message button. You click that and you go back to the LIP, and you'll see that it has turned green. So now the LIP is commissioned and online. Remember that this step where you commission the LIP and it turns green is only necessary when you have the LIP in configured router mode. If you're using SmartSwitch, just place it on the drawing, set it to repeater, and then do nothing more with it. Now you open up the system plugin. Depending on your version of Visio, it's located in different places. This version is 2010, so it's in Add-in, LunMaker, Plugins, Network Plugins, and TAC Vista System Plugin. You open up the plugin and you perform the required steps to update the TAC Vista database. Click Update, click Check, and if this would have been a real installation, you would click Create Group Binding and synchronize the Visio drawings to the database. I'm going to perform this just for the documentation and for the practice, but of course I have no units in my database, so nothing will really happen. After the synchronize, I go back into the system plugin. I then select Update Vista Database, and yes. Here at first the update is going to fail. This because in the TAC network settings we haven't selected the appropriate interface. First we have to select the name of our Vista server. So we click on the Vista server and click Select. Then the port type. So this is not LNS now, this is a Loytec port. You can again write the interface name, it will appear in Vista. I'm just going to leave it with LNS. Click Loytec port and select the appropriate interface for the PC. And now click OK. So now we should be able to update the Vista database. After that, if any unit had been on the network, we would download them. And at last we would, in the TAC network, click on Commence Communication, which of course here is grayed out. Now back in TAC Vista Workstation, you can see here that the interface has been added under the server. You can see that the name is correct, which port has been selected, and the network name is the same that was appearing from our LNS database. In SmartStruxure, it's easier than ever to add the Loytec interface. There are a couple of different ways of doing it, and I'm going to show two of them. Using the first method, we are assuming that we are online with the system. I go to Device Discovery, click LUNWorks, and after it's finished searching, I can see my 8 virtual interfaces for my NIC 852. As LunMaker is starting from selecting virtual interfaces from one end and TAC Vista is starting from the other end, I would suggest that you take one of the virtual interfaces somewhere in the middle. Pick the interface and drag it onto your enterprise server. Now you can see that the interface is taken and you have the interface represented under the ES. You make a new LunWorks network onto the interface, and as you can see, when you right click, there's no commission menu here. This is because the network is automatically commissioned. So now I'm going to show you the second method, which is my preferred method. Let's say that you are making this enterprise server database, but you're not online with the system, and you may not even have a Loytec interface on your PC. In that case, you start by making manually a new interface under the enterprise server, select LunWorks interface, and click Create. Then under the LunWorks interface, you create the new network. And actually now you can make your complete database with LUN units even though they are offline. When you take the properties for the LUN voice interface, you can see here that the network interface name is null, non-existing. So it's purely a logical representation. Now we simply go as before to device discovery. When we go online on the site, select the interface and drag it onto our logical interface. Now you can see again the interface is now taken, and if we check the properties for the interface, now we can see that it has an actual physical interface defined and it's online. And now for the last part of the presentation, which is troubleshooting communication. As good as a firewall can be for security, as annoying it can be when you're trying to get something to communicate over the network. Always try, if you have communication issues, to disable the firewall for a start. And if that is working, then start tweaking the firewall. The firewall should always allow inbound communication to the port configured in the driver and outbound communication on all the ports that are used on the slave and config LIPs. Built into the LIP, you have a great tool for troubleshooting communication between the LIPs and also the PC. In the enhanced communication test, you'll see what LIPs are online and how fast they communicate. Also, if you're using a more advanced environment where you're using NAT, if there are any errors in the NAT configuration, this will show up here as well. Last but not least, we'll talk a bit about UDP communication. Especially when working with a WAN setup, it can prove to be hard to troubleshoot the communication. As UDP is not a session-based communication form, you can't use tests like telnet commands. I normally make the comparison between UDP and TCP, like a walkie-talkie and a telephone. Using a telephone or TCP, you will always know if the person in the other end has picked up the phone and if the person is answering you. When you use UDP, you just press the button and talk, but you have no indication whether the person in the other end has actually heard your message. That is how UDP and TCP works on a network. So to test UDP communication, you need something in both ends. I've found SimpleCommTool's UDP test tool program very useful in these cases. With that, you can select when to send a test and to what device. It's a good way to test if, for instance, the communication from the PC to the LIP is okay, but not the other way around. This tool can help point to NAT errors in routers. So here I have to open up the program. First of all, when you use this program, remember to close all programs or all applications using the Loytec driver. If you don't do that first, the test won't work, as the specific port on the PC is already taken. Start by, on the host side, entering the port used or configured in the Loytec driver and click bind. Already now you can see that I'm receiving communication from my config server. On the remote side, you can write the IP address on the LIP or the PC to which you want to test. Write the port, enter a message that you want to send to that IP address and port, and click send. Remember that to probably test this communication, in the other end you would have disconnected the LIP with this specific IP address and put another PC with that same IP address there instead of that. So on the other PC, you would see the message in this edit receive data window. I'm going to send a message back now from that PC, and you can see a hello world back. In the list you can see the data from the different IP addresses, and you can see that this PC sent this message back. So this concludes my presentation. I really hope that you found it useful and inspiring. As always, please feel free to comment or give ideas for improvements.